error correction topic. Okay, so this topic is known as Hamming code. So this type of code you have already done. You may have already done in digital electronics. If you haven't done it, you can refer to today's lecture. If you remember, it's well and fine. Okay. So now, what exactly is a Hamming code? So Hamming code will be used for 1-bit error correction. Okay, so 1-bit error correction. Because 1-bit error is the most frequently occurring error, that is why we use Hamming code for it. Okay, so now in the previous error detecting algorithms, what we have done is that we have been able to detect the error, but we are not able to correct it. Okay, so Hamming code will be able to tell that at which particular position you have faced the error, and it can rectify that. Okay, so now suppose this is the message. Now with the message we have to send some parity bits. Okay, so this parity bits, now you see there will be cases. Okay, so there are cases like there are m plus p plus 1 possibilities. Okay, so the m plus p possibility is that if you are sending 4 bits of message, suppose if you are sending 4 bits of message and you're sending suppose 3 bits of sorry 2 bits of parity. So I don't know how the parity bit will be set, I'm just taking an example. So it is saying there are 4 plus 2 plus 1 possibilities. Now 4 plus 2 possibility is that there are 6 bits. Now there are total 6 bits that you have sent, and there may be a error in any of the 6 bits. Okay, so 6 possibilities are if you're sending this bit data including 1 2 3 4 5 6, you're sending 6 bit data. There may be a possibility that you have a error in first bit or second bit or third bit or fourth bit or fifth bit or sixth bit. Okay, so these are 4 plus 2 possibilities that you may have error in either of the 6 bit, and one possibility that there is no error at all. Okay, so 4 plus 2 m plus p possibilities that there is error in either of the 6 bits or either of the total bits, and one possibility that there is no error at all. Okay, so I still don't know how to set how many parity bits should be here. Okay, so in order to calculate all the possibilities, the parity bit is such in that way. Okay, so if I want to set the parity bit in such a way that I may be able to detect all the possibilities, that is total 7 possibilities. Okay, so I say that with the help of this p, I'll say it is raised to the power of p. So the if I set p, how many possible combinations of p can be possible? It is 2 raised to power p. So I'm saying that 2 raised to power p should be greater than or equal to m plus p plus 1. Okay, so if it is equal to, I think I may be able to cover all cases, but if it is greater, because I am sending 2 raised to power, so it can happen that in some cases it would be greater. Okay, so there is no problem. I will not use any of those cases. Okay, so suppose I'm sending 4-bit message. I don't know what will be the parity bit here. Now in this particular case, what will happen? 4 plus p plus 1. Okay, so there are total 4 plus p cases, 4 plus p cases in which error can occur at any position. Okay, so I do not know what p is, and one case there is no error. Okay, so there will be total p plus 5 cases. Okay, so I have to tackle these p plus 5 cases. Okay, so how can I tackle it? You can tackle it with this formula. Okay, so I have to set the value of p in such a way such that it can tackle p plus 5 cases. So I can write 2 raised to power p should be greater than p plus 5 cases. Okay, so now if I put the value of p to be 1, what will happen? 2 raised to power 1 is greater than equal to 1 plus 5, which is 6. Okay, so which is 6, that is wrong. P equal to, when I set the value of p equal to 2, it will be 2 raised to power 2 greater than 2 plus 5. It will be 4 is greater than 7, which is again wrong. If I take the value of p to be 3, it is 2 raised to power 3 should be greater than equal to 3 plus 5. Okay, so it will be 8 is greater than equal to 8. So this condition is true. Okay, so that is how the value of p is set. Okay, so now the value of p in this case will be p plus 3 uh, should be now, if you're seeing here, I'm sending a 8-bit message. Okay, so now understand this very good, understand this very carefully, that I have set the parity bit as 3. Now 4 plus 3 bits is greater than equal to, the total cases will be 4 plus 3 cases that there may be error, and one case that there is no error. Okay, so how can you set it? Because we know that the parity bit is 3. Now I will be able to compute all the 8 cases. Okay, so now why I will be able to compute all the 8 cases? Because you say I'm writing the cases that 0 0 0, with the help of these 3 parity bits I will be able to generate 8 cases. Okay, so 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 4 5 6 and 7. Okay, if you take it, look at it, it will be total 8 cases from 0 to 7. Okay, so this particular case indicates that there is no error, and all the remaining cases indicate that either there is an error in first bit, or there is an error in second bit, or there is an error in third bit, or there is an error in fourth bit, or there is an error in fifth bit, sixth bit, seventh bit. You get my point. Okay, so again, I'm only saying that there is an or in all of this. Okay, so I'm only using this method for calculating 1 bit method. Okay, so a 1 bit error. Because if the error is more than 1 bit, I may not be able to detect it by using this method. Okay, so it is also ensuring, because you are sending the message as 4 plus 3, sorry, 4 plus 3 as 7 bits. So there may be total 8 cases. So it is also, because you are sending the message in such a way, it will be arranged in the bits like 1 0 1 0 1 0, something like this, 1 2 3 4 5 6 7 bits. Okay, so there may be error in this bit, there will be error in bit this, or there is no error. So 8 cases are handled by at least 3 bits. Okay, so if that is why the parity bit is set in such a way that it may be able to handle all the 8 cases. Okay, so again it is also handling the, because you are sending the parity bit also, so parity bit will also be set in such a way that this will, if there is an error in parity bit, it will also be corrected. I'll show you how to set the parity bit. Okay, so now if you understand it here, now to calculate that how can you get the parity bit, you have to remember this particular formula. Okay, now it's not a remembering. If you understand this formula, that I need m plus p cases, m plus p cases will tell you that there is an error in any of the position, and one case will tell you that there is no error. Okay, so now suppose I am sending some message. I'll take an example. Okay, so you can refer to any example. If you refer to Geeks and Geeks for Geek site, there will be an example there, or any other examples you can refer it. Okay, so when the message size is 4, okay, so now the message that I want to send is 0 1 0 1. Suppose something like this. Okay, so now what the message bits here is m plus p. It will be able to detect m plus p plus 1 cases. Total this will be the cases. So 4 bits are here, and p, it will be again the same thing. Okay, so 4 plus p plus 1. So total 5 plus p cases will be here. Okay, so how to set the value of p here? Okay, so how to set the value of p here? P, it's 2 raised to power p should be able to greater than m plus p plus 1. Okay, so what is this actually? It is 2 raised to power p. It is m plus p. We have solved it. It is 5 plus p. And if you put the value of p to be 3, you will be able to get the right answer here. 2 raised to power 3 is 8. It is greater than 8. Okay, so now you know that the number of bits in parity will be 3 bits. Okay, so one thing you also know this. Okay, so now the first step, that how to set up the parity bits. Okay, so at every position of 2, or at every power of 2, the parity bit will be set. Okay, so every power of 2, add your parity bits. So I'll show you. So now what is the message 0 1 0 1? So I'll say that 1 2 3 4 5 6 7, because I will send 4 plus 3 bits. Okay, so 4 bits of the message, 3 are the parity bits. Okay, so now what is the position of the parity bit? I have to, the first step is to identify the position of the parity bit. Okay, so at every power of 2, add parity bits, because there are 3 parity bits. So 2 raised to power 0 is 1, 2 raised to power 1 is 2, and 2 raised to power 2 is 4, and 2 raised to power 3 is 8. Okay, so these are the number of parity bits. Okay, so 2 raised to power 0, I have to set this is parity bit 1, 2 raised to power 1, it is parity bit 2, and 2 raised to power 2 is 4, that is parity bit 3, and there is no 8 in this position because total 7 bits we are sending, so that is there is no need to include 8 here. Okay, so now the remaining bits are your message bit. So this is first message bit, second message bit, third message bit, fourth message bit. Okay, so what is the message here? So I'll write the message as 0101. Okay, so I can write that this is 1, this is 0, sorry, 0 1 0 1. Okay, so the now the question is, I have to set this parity bit. Okay, so how can you set this parity bit? Again, you can, if you are looking at in any book, you can directly see the position here. So I'll also tell you that how actually each parity bit is derived, that this particular parity bit will take care of which message bit, I'll tell you. Okay, so in order to do that, now the second step is to is to set the parity bits. Okay, so I have to set the parity bits. So for setting the parity bits, you have to know, suppose there, because we already know how many bits are there. There are total 3 parity bits. Okay, so 3 parity bits, we are able to generate how many cases? 8 cases. Okay, so I'm just writing the cases here. So I'm writing P1 here, P2 here, and P3 here. Okay, so P1, P2 here. Remember this order: P1, P2, P3. Okay, so you write 0, 0, 0, all the binary combinations: 0, 0, 1, 0, 1, 0, 0, 1, 1. So 3, 4, 5, 6, 7. Okay, so these are the binary numbers I'm writing that are possible with 3 parity bits. Okay, so this particular case generate that there is no error, this generate that there is an error at first bit, error at first, so I'm writing error at first. It will indicate error at second, uh, this is third, fourth, fifth, sixth, seventh. Okay, so now understand this one, that now I will take care of this. Now parity bit 1 will be set according to wherever the 1 is. Okay, so where is this 1? So this is 0, this is 1, 2, 3, 4, 5, 6, 7. Okay, so now P1 is 1 at this position. This position is referred to as 1. This position is referred to as 3. This position is referred to as 5. This position is referred to as 7. And then just wait a minute. Okay, so how can you set this parity bit P2? Now parity bit P2 will be set on the same basis. Okay, so this is their second parity bit. So where is this 1 there? The 1 is at the second position, so I'll write 2. The 1 is at the third position, you can write 3. The 1 is at the sixth position, you can write 6. The 1 is at the seventh position, you can write 7. Okay, in a similar way you can check for P3, that is parity bit P3, that is 4, 5, 6, and 7. Okay, so you can write 4, 5, 6, and 7. Okay, so now what you do now, keep in mind, now if I write the same thing here, see here. Okay, so it is saying that this parity bit 1, so I have to set the parity bit at position 1. So this is the position here. The parity bit position 1 will take care of the positions 3, 5, and 7. So this 3, 5, and 7, based on these positions, that's 3, 5, and 7, this parity bit will be set. Okay, in the similar way, parity bit that is present at position 2 will will be based on these 3 positions, that is 3, 6, and 7. Okay, so 3, 6, and 7. Okay, in the similar way, parity bit at position 4 will take care of the will be set on the basis of these 3 position, that is 5, 6 and 7. Okay, so 5, 6 and 7. Okay, so I'll show you how can you set it. Okay, so you already know that parity bit 1, sorry, I can write the position 0, 1, 2, 3, 4, 5, 6, 7. So 2 raised to power 0, 2 raised to power 1 and 2 raised to power 2. Okay, so now this is actually your message bit, so I'm writing the message, that is 0, 1, 0, 1. I think that was the message. Okay, so now how can you set the number here? So P1 is based on 3, 5 and 7. So check this 3. At 3 position 0 number is there, at 5 position 1 number is there, at 7 position 1 number is there. Okay, so it is odd, it is a even parity. Already it's a even parity, so what you do, you add a 0 here. Okay, so the similar way, the second parity bit, the second position will be taken care by looking at 3, 6 and 7 position. So at 3 there is a 0, at 6 there is a 0, at 7 there is a 1. So it is a odd parity, so to make it even I have to add a 1 here. Okay, in the similar way, at the fourth position you take a look at 5, 6 and 7. So 5 is odd parity, 6 is still odd parity, and 7 is even parity. So this is even parity, you can write a 0 to complete the even parity cycle. Okay, so now this is the message that you will send across the medium to the receiver. Okay, so now how can you, suppose now if you send the message, I am assuming that one bit is got corrupted on the way. Okay, so I'm assuming that one bit got corrupted on the way. Suppose the message is sent like this, the message sent, and on the way the message the message is 0, 1, 0, 0, 1, 0, 1. Okay, so the message that is received by this one is 0, 1, 0, 0. So suppose this particular bit got corrupted. Okay, so 0, 1, 0, 0, and then remaining is 0, 1. Okay, so now what this particular receiver will do, now when you are sending the parity bits, the check bits will be set by the receiver. Okay, so whatever is the parity bit, the check bit will be the opposite of that. Okay, so if this is, because there are 3 parity bits, there will be 3 check bits. Now whatever is the parity bit here, so parity bit here is written as P1, so check bit here you can write it as C3, check bit here you can write it as C2, check bit here you can write it as C1. Okay, so whatever is the parity bit, you the exact opposite is the check bit. Okay, so it is C3, C2 and C1. Okay, so now what you do, you just check the check bits on a particular position. So check bits can be written like this: C1, C2 and C3. So C1 check bit is based on 4, 5, 6 and 7th position. Okay, so now I'm writing the position number here: 1, 2, 3, 4, 5, 6, 7. Okay, so now what is the how can you fill this particular position? By checking the check bits, that is 4, 5, 6 and 7. At 4, 5, 6 and 7. So at 4 position 0, 5 position 0, 6 position 0, 7 position 1. Okay, so actually it is a odd parity, so you have to complete it to make it even. I am adding 1 here. In the similar way, check bit 2 is set on 2, 3, 6 and 7. So 2 is odd parity, 3 is still odd parity, 6 is odd parity, and 7 is even parity. So I am not adding anything, so that is 0. In the similar way, C3 is check on 1, 3, 5, 7. Okay, so 1 is even parity, 3 is even parity, 5 is even parity, and 7 is odd parity. Okay, so there is only 1 in there, so it is odd parity. So you can add 1 to make it as even. Okay, so now if you take a look at it, this is the binary number, this is the decimal number 5. So it is telling you that there is an error at the 5th position. Okay, just wait a second. Okay, so you can take a look at it. It is saying that your error is at a 5th position, so you can count it. So this is the position of the error. So actually it was 1, 2, 3, 4, 5th position I got the bit as corrupted. Okay, So if you want to understand it how it is actually working, it is like what you say, it's a set theory based question. Okay, so if you're seeing here actually what is the meaning of this C11. C11 means that whatever is the bit here, whatever is C1 is supposed to take care of the bits, there is an error in that bit. In the similar way, C31 means that whatever is C3 supposed to take care of the bits, there is an error in any one of them. So C1 is taking care of what bits? It is C1 is taking care of 4, 5, 6, 7. So 4, 5, 6, 7, and C3 is taking care of 1, 3, 5, 7. Okay, so 1, 3, 5, 7. So take out the common bits here. So what is the common bit in these two? So it is 5 and it is 7. Okay, so you can think that either there is an error in 5 or there is an error in 7. Okay, so now you can understand that C2 is saying 0. Okay, so if C2 is saying 0, it is saying that in my in the bits that C2 is supposed to take care of, there is no error in these bits. Okay, so what are the bits here? So what are the bits here? 2, 3, 6, 7. So it is saying that C2 2 in 2, 3, 6, 7, there is no error. Okay, so 2, 3, 6, 7, there is no error. So you can directly do a set difference. Okay, so when you do a set difference between these two, you will find that there is an error in fifth position. So you can also think it like that. It is actually behaving like a set theory. Okay, so now this is I have taken a set difference here, so a minus b. So the definition of it will be the elements of a which are not in b. Okay, so the elements of this a, this the elements of a which are not in b uh, are the elements of a which are not in b are only 5 is the element that is in a which is not in b. So that is how the set difference is calculated. Either you can directly delete this part, and whatever is the at the a present here, you can write it directly. Okay, so this is the underlying concept. How do you get how to do it? Okay, so now only three things you have to take care. I've shown you the derivation here, but actually you can directly because this is the first time you are doing this Hamming code, so I have actually show you the derivation, that how can you derive at which position this check bits will be set. Okay, so it can also happen the parity bits will be 4. Okay, so if the parity bits are 4, again you have to set the check bits here. Okay, so I'll show you for the 4 cases as well. But by just understanding this, that C1 uh, just I'm copy and pasting this. So by understanding this particular thing, you can solve any question. There is no need to derive it. So I'll tell you the pattern also if you do it. So I'll tell you the pattern in the end. How can you just uh, logically derive out? But based on these things, your question will be set. So you have to know the check bits as well. You have to know the parity bits. Okay, so keep in mind the check bits will be totally reverse of the parity bits. Okay, so based on these three things, I am again giving you a message. Message is 1100. Okay, so you just tell me what will the sender send. Okay, so just tell me uh, based on these things what will be the sender's message to the receiver. Okay, so just tell me what will be the answer here. So I'll again repeat it if you are not understanding it, so that I move on to the next question with good example. Okay, so big example. Okay, so try it and show me in the chat box if you have derived it.
Sir, is it 0 1 1 1 1 0 0?
It is 0 1 0 1 1 0 0. Sorry. Again, can you repeat the pattern?
0 1 1 1 1 0 0.
Yeah, absolutely correct. Absolutely correct.
Absolutely.
Well done. Okay. So again, I'll show you if you're not understanding it. If you keep this particular thing in your site, I think you will be easily able to extract out the message. Okay. So because these are 4 bits, you already know that the parity bits will be 7. Okay. So total parity bits will be 3. So the total message will be of 7 length. Okay. So I'm writing it 1, 2, 3, 4, 5, 6, 7, and you already know how to set the parity bits here. So parity bits will be 2 raised to power. Okay, so this is P1, P2, and this will be your P3. Okay, so I have to write the message as 1, 1, 0, 0. Okay, so how to set the remaining parity bits here? So the remaining parity bits, the P1 will be set on these three positions, that is 3, 5, and 7. So check it. 3 at 3 it is odd parity, at 5 now it becomes even parity, at 7 it is now even parity. So you have to add a 0 to keep the parity as even. So the second parity bit will take care of 3, 6, and 7. What is 3? So at 3 it is odd parity, at 6 it is still odd parity, at 7 it is still odd parity. So you have to add a 1 to take care of the odd parity to make it even. In the similar way, at the fourth position will be set by 5, 6, and 7. Okay, so at 5 it is odd parity, at 6 it is odd parity, at 7 it's odd parity. So you have to add 1 to make it as even. Okay, so again, uh, this will be your message that will be sent towards the sender, towards the receiver here. So suppose this message got this particular bit got corrupted here, so the message becomes 0 1 1 1 0 0. Okay, so everything remains the same. So I have to check the check bits. Okay, so at c1 will be set based on 4 5 6 and 7. So 4 is 1, this is odd, 5 is even, odd, even, so still it is even, so I'm adding a 0 here. So for C2 it is 2 3 6 7. So 2 is odd, 3 is odd, 6 is odd, and 7 is odd. So you can add a 1 here to make it even. So 4, now I think for the check bit C3 I have to check 1 3 5 7. So 1 is even, 3 is even, 5 is odd, 7 is odd. So you have to add a 1 to make it even. Okay, so it is saying that you got a error at the third position. So it is 3, actually it is 3. So in this way you can figure it out. Okay, so now what will happen if I increase the size of the message? Okay, so suppose I increase the size of the message as 5 bits. So again, you have to follow the same procedure in this particular case. What will happen at it will become m plus p. So the total cases will be m plus p plus 1. Okay. So what is m here? Message bit is of 5-bit length, and what is the p here? So I do not know the p, and it will be 5 plus p plus 1. So it will be p plus 6 cases it will be there. Okay, so now how to set this p? So you already know it will be set by this formula, that I have to be able to take care of all the cases, that is p plus 6. So it should be able to derive out all the cases, it is p raised to power 6. Okay, so what I'll do, I'll write 2 raised to power 3 greater than 3 plus 6. So it is 2 raised to power 3 is 8, it is greater than equal to 9. So this statement is wrong. So I have to set the value of 2 raised to p as 4. Okay, so 2 raised to power 4, 4 plus 6. So it is actually 16 is greater than equal to 10. Okay, so actually there will be only total 10 cases. There will be extra 6 cases here, because that is why I've shown you that why it is greater than equal to, not equal to, because the 6 cases are no use to me. Okay, so I'll show you why these 6 cases are not no use to me, because the bits are only 10. Okay, so if you're seeing here, I will send, sorry, the bits are only, I will send 5 message bits plus 4 parity bits, and the cases, total cases are 5 plus 4 plus 1, that are 10 cases. So actually there are only 9 bits here. Okay, so 9 bits Error can be at any one of the 9 bits and one bit that shows that there is no error. So actually there are total 10 cases and there are extra 6 cases that you will get by setting the parity bit as 4. Okay, so there are only two options. Either you can set the parity bit as 3 or you can set as parity bit as 4. But I cannot set the parity bit as 3 because the cases are less here. If I set the parity bit to 4, the cases become more here. So I'll show you what is the meaning of this. Okay, so now again you have to write the same thing, that is P1, P2, P3. Now the parity bits are 4 here. Okay, so how many numbers will be set? So actually it will be 0 to 15. So if I write it, it will be 0 0 0 0. So this is just a binary numbers I'm writing: 0 0 0 1, 0 0 1 0, 0 0 1 1. Okay, so 3 4 and then 5 6 7 8 9 10 10 11 11 12 8 plus 4 12 13 12 plus 1 13 and 14 13 14 14 is 8 plus 4 12 12 plus 2 14 and then there is a 15. So all are ones, then there will be a 15. Okay, so again with the help of this 4 parity bits I will be able to see total 16 cases, but out of these 16 cases only 10 cases are useful to me. Okay, so this is 0th case: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Okay, so there are total 15 cases, but if you already know that this case denotes that there is no error, this case denotes that there is an error in first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, eighth bit, ninth bit. Okay, so only there are total 9 bits. So I may not be able to utilize these cases because only I have, but the total I have 9 bits that I'm sending. Either the error will be in one of the 9 bits or there is no error at all. So the remaining cases I may not be able to utilize. Okay, so if you're setting the parity bits here, the parity bit will actually be this is 1 1 3 3 5 5 7 7. Now if you go again a little bit further, it will be 9. So out of that I will not may not be able to utilize it, but still you can write it. It will be 11 13 and 15. So P1 parity bit can be the parity bit that it is present at position 1 will be based on these to a particular positions. Okay, so in a similar way, parity bit on position 2 will be based on 2 3 6 7 uh, 2 3 6 7. I don't think that after that it will be useful, so still, but I'm writing for just for the sake of for the sake of completeness. Okay, so it is 10 11 14 15. Okay, so 10 11 14 15. Okay, in the similar way P3 will be 4 5 6 7. So it is the same thing, 4 5 6 7, that we have already derived out. But there are also one thing here, that is 12 13 14 15. 12 13 14 15. Okay, so in the similar way the parity bit P4 will be set as 8 9. So only 8 9 will be utilizable, but other than that I'm just for the sake of completeness I'm writing 10 11 12 13 14. Okay, so 10 11 12 13 14 15. Okay, so now if you want to see the check bits, check will be the completely reverse. Okay, so your check bit, if it is starting from P1 here, it will be the C check bits will be started from C1 here, C2 here, C3 here, C4 here. So okay, so it will be completely reverse of it. Okay, so I can write P1, I can start it with C1 C2 C3 and C4. So that is how the check bits will be. Okay, so now when you are setting the message, now I just write the message as it is. So what is the message here? So just assume any message. Okay, so I'm assuming the message as 5 bits, so it is 1 1 0 1 1. Okay, so this is 5 bits. Now I'm writing because I will send plus 3 parity bits. So 5 plus 3 will be 8 bits. Yeah, yeah, okay. So 1, 2, 3, 4, 5, 6, 7, 8. Sorry, it will be 4 parity bits. 9. Okay. So total 9 positions will be there. So you already know how to set the parity bits. That is step 1 is to set the parity bit on the powers of 2. Okay, so the power of 2, 2 raised to power 0 is 1. So parity bit 1, parity bit 2, 2 raised to power 1, 2 raised to power 2 is 4, the parity bit 3, 2 raised to power 3 is 8, the parity bit 4. Okay, so there is no if you raise it to the power of 5, 2 raised to power, sorry, 2 raised to power 4, it will be 16, but there is no 16 position here, so I'm just stopping here. Okay, so I've stopped here. Okay, and after that you already know what is the message here. So these are the message bit m1, m2, m3, m4 and m5. Okay, so the procedure is same. So it is 11011. So this is 11011. So I have to set these bits. Okay, so I already know how to set these bits. Okay, so how can you set these bits? So p1 will be taken care of this position 3, 5, 7 and 9. Okay, so 3, 5, 7 and 9, because this particular is not useful to me because there is no position 11, 13 and 15. So again I'm saying that only the cases that are utilizable for me is only till here. After that these particular cases are wasted. Okay, so now check it. 1, 1 I have to set it. 3 it is a odd parity. 5 it is a even parity. 7 it is a odd parity, and then 9 it is a even parity. So I have to add a 0 here. And for p2 it is 2 3 6 7, 2 3 6 7 10. So I am only able to utilize till here, so these cases are not useful to me. So 2 3 6 7, 3 is odd parity, 6 is odd parity, 7 is even parity. So you have to add 0 to make it, to keep the parity as even. Okay, so the similar way, I don't think after that any case will be useful to me. So only 4 5 6 7 is useful. So 5 6 7 check. 5 is odd parity, 6 is odd parity, 7 is even parity. So I have to add 0 to make it as even. So parity 3 is set by 0 here. Okay, so now in the similar way, you are only this much will be utilizable, that is 8 and 9. So you can check it. 8 position is set by 9, so 9 is a odd parity, so you have to add a 1 to make it as even. Okay, so again this particular message will be sent again to the receiver. If you want to check it, that how the check bits work, so I'll show you. So suppose there is an error. Suppose there is an error at 7th position. So I'll change this one. So okay, that is the advantage of this particular binary number system, is that when you are able to figure out the error, you just have to reverse the bit, because there are only two possibility, either it will be 0 or it will be 1. Okay, so now if I am able to figure out that there is an error at 7th position, the receiver can go at the 7th position and reverse this bit. Okay, so now in this particular case you will be seeing here that there is no actually there is no usage from the, what do you say, from the sender side. Okay, so the only the processing is done totally at the receiver side. Okay, so that is the advantage of it. So the receiver does not bother sender about by sending a negative acknowledgement and say that please send the packet again to me. So that is how this is very useful, because it is reducing that time for sending the packet again and again. Okay, so that is the usefulness of this. Okay, so now if you figure it out, what you do, you have to know the check bits here. The check bits, take a look at the check bits here. So for c1, then there is a c2, and there is a c3, and then there is a c4. Okay, so at c1 if you check it, it will be based on 8 and 9. Check the position 8 and 9, it is even parity. So what you do, you check, you write a 0 here. So it is saying, actually it is saying at 8th and 9th there is no error. Okay, so it is actually saying this, that because there is a 0, it is saying at 8th and 9th position the bits are the bits that the sender is intended. Okay, so now see for c2, now check, c2 is 4 5 6 7. Okay, so 4 it's even parity, 5 it's odd parity, 6 it's odd odd parity, and 7 it's odd parity. Now it is saying at 1, so I have to make it even parity, I have to make it 1. Now it is saying at check bit 2 that there is a either that there is an error in either of these four positions. So actually it is saying by saying a 1 here. Okay, in the similar way, check for C3. C3 is saying 2 3 6 7. Okay, so 2 is even parity, 3 is odd parity, 6 is odd parity, and 7 it's also odd parity. So again this position is saying that there is an error in either of these bits. Okay, so actually there is an error in 7th bit here, 7th bit here, so that is why this is 1 and 1. Okay, so if you check it for C4, there is again a 7 bit here, it will again be 1 here. Okay, so check 1 3 5 7 9. Okay, so 1 is even parity, 3 is odd parity, 5 is even parity, 7 is even parity, and 9 it's odd parity. So you have to make it even by taking a 1 here. So what is this 111? If you figure it out in terms of decimal, it will be 7. Okay, so it is 7. So it is saying that there is an error at the 7th position. Now what the receiver does, what the receiver is doing, it will go towards the 7th position and it will inverse the bit to 1. Okay, so that is how your error detection using Hamming code works. Okay, so you may have done this similar kind of thing concept in digital electronics as well. So this is the concept behind it. Okay, so there is no need to remember anything, you can derive it on the spot. But if you have given a question of Hamming code and you started deriving it, it will take a lot of time. So if you can figure out a pattern here, so you can easily see what is the pattern here. Okay, so for this when you're setting 4-bit, you will be able to see what is the pattern. Okay, so pattern in case of 4 bits here is first pattern is 1 3 5 7 9 11 13 14. So this is just odd numbers. Okay, second pattern, if you see it, that there is a difference of 1. Okay, so 2 3, the difference of sorry, in the first one there is a difference of 1, in the second position there is a difference of 2. Okay, so difference of 2 starts from 2 3, then there is a difference of 2, and then starts for 6 7. You check 2 3 6 7, difference of 2 of 8 9, then 10 11. Okay, so again leave 2 12 13, it will be 14 15, and again you can go on. Okay, so in a similar way the pattern will be for C2 here will be, if you check it, it will be 4, the difference of 4. Okay, so it is starting for 4 5 6 7, and you leave 4 7 8 9 10 11, you leave 4. Now 8 9 10 11 is 4, you check here 8 8 9 10 11, again there are ones at 12 13 14 15. Okay, so there is a difference of 1, there is a difference of 2, now there is a difference of 4, and now here will be a difference of 8. We check it, it is the first 8 are 0, and it will starting from 8 to 15 are 1 here, 8 to 15 are totally 1 here. So again the difference is also based on these things, 2 raised to power 2, 2 raised to power 1, 2 raised to power 2, 3, and 2 raised to power 4. Again keep in mind that it is only in the case of when there are 4 parity bits. Okay, so if you check it, I think you will find it that here for till parity bit 3, that this particular pattern holds there also. Okay, so if you check it, the parity bits here, you will see this particular pattern is holding there also. Okay, so where is the pattern? Sorry, yeah, this is the pattern. Okay, so you see there is a difference of 1 here, 2 raised to power 0, 1 3 5 7 odd numbers. There is a difference of 2 here will be 2 3, then there 4 5 is leave, 6 7 is there. Okay, so then there is a difference of 2 here, that is 4 4 5 6 7. So the first 4 are left, and 4 5 6 7 is the difference. Okay, so you can go further than that. Again the difference, if you want to check the parity bit of P4, the difference will be 2 raised to power 3. If you want to set the P5 parity bit, it will be 2 raised to power 4. Okay, so that is how your pattern works. Okay, so if you understand this pattern, there is no need to remember it. Again, if you forget it, so basic idea is there. Okay, so you can get the basic idea by listing down the numbers, but still I think if you figure out the pattern yourself, it will be easier for you. Okay, so with this, your error correction and error detection, so both the modules of error handling is completed. So again, keep in mind, in error correction only there is one technique. Okay, so that is your Hamming code. Okay, so there is no other technique that can detect the error. There is only one technique, that is your error this Hamming code. Okay, so again, the remaining topics are some IEEE standards, so I'll try to cover it in the next one. So again, just revise all the things that you are supposed to, because there is a quiz on Tuesday at 6 p.m. So just if you have any doubt, you can ask me on mail as well as on Teams. If you have any doubt here in this particular lecture, you can ask me here as well. Okay. Okay, so if you want to lecture is